dance.
Okay, this is my name is Sanda Shakib. I'm a student of Body Kampala SS, offering EMTD, doing revisions of different subjects of both O and A level. We're doing this voluntary, and in case of any help, you can reach us through our page, and we seek any advice where necessary. Today, I'm going to take you through mathematics, paper 1, A level, and today we are going to concentrate on quadratics. In quadratics, we make subtopics with solving equations. We have completion of squares. We have quadratic formulas. And we have discriminants of quadratic equation. We have simultaneous equations. We have curve sketching. And we have the last one, which is called maximum and minimum. But for today, we are going to concentrate on completing squares and discriminant of quadratic equation. For solving and quadratic formulas, those are all level work, which I know you completed it. But for now, we are going to concentrate on completing squares and discriminant of quadratic equation. They may give us a quadratic equation of ax squared plus bx plus c. To put it in form of a into x plus b squared plus q, where p and q are constants. So let's get an example for that. They may give us a number like this: x squared plus 10x minus 3. To put it in form x plus b squared plus q. When they give us a number like this, first of all, we need to have the coefficient of x, which will become x plus 5 squared minus 25 minus 3. Somebody there may wonder where we have got this 25 from. When we complete this, like here, x plus 5, and we complete it, we are going to get x squared plus 10x plus 25. The question was given only x squared plus 10. So this 25, we are gonna subtract it from 25 as well here to meet the conditions of the question. So by doing this, we are gonna get x plus 5 squared minus 28, and this is the answer. So we are gonna look at another situation where they can give us a number like this: 2x squared minus 12x plus 1, to put it in form of ax plus b squared. So here we are gonna get, we are going to first consider the first two terms, which is 2x squared minus 12x, but they have told us to put a coefficient of a out of x plus b. So we are gonna factorize out b, which is gonna be 2x squared minus 6x plus our 1 also, and then we complete the squares of this bracket, which will be 2 into x minus 3. When we have this, we shall get 3, becoming x minus 3 squared minus 9 into brackets plus 1. When we enter 2 in the brackets, becoming 2 into x minus 3 squared minus 18 plus 1, becoming 2x minus 3 squared minus 17, meeting the condition of the question. And another, they can give us another confusing question, which will be in the form of, which can be in the form of 3 plus 4x minus x squared, to put it in form of q minus x plus b squared. So first of all, we need to make the squared to be a positive one. So we are gonna get a negative out of the brackets, making it positive, and these others will become negative, of course, minus 4x minus 3. By completing squares, we shall get negative outside the brackets, x minus 2 squared minus 4 minus 3, getting a negative outside, x minus 2 brackets minus 7, but they have told us to put it in the form of this. So we are gonna enter our negative one here into the brackets, becoming negative into x minus 2 squared plus 7, becoming 7 minus x minus 2 squared, which is the form they have given us. So for now, we are gonna complete the squares of an equation, which will be like this. They can give us an equation like this: x squared minus 6x plus 2 equals to 0. To put it in the form of x equals b plus or minus into root cube. So here they have told us to make x the subject, but we need to complete the squares of this equation, becoming x minus 3 squared minus 9 plus 2 equaling to 0 shall get x minus 3 squared minus 7 equaling to 0. But they have told us to make x the subject, so we are gonna take 7 the other side, becoming x minus 3 squared equaling to 7. We need to take away this square, and then we shall square root on both sides, becoming x minus 3 equaling to plus or minus root 7. Taking 3 the other side and making x the subject, it will become 3 plus or minus root, and we have answered our question. And using example maybe x squared minus 3x minus 1 equal to 0, to put it in form of x equals to p plus or minus into root q over 2. Doing the same, we shall complete the squares being x minus 3 over 2, because we are having the coefficient of x minus 3 over 2 squared minus 1 equal to 0, becoming x minus 3 over 2 squared minus 9 over 4 minus 1 equal to 0. By computing this, we are gonna get x minus 3 over 2 squared minus, if we complete this, we are gonna get like let me see, 4 to be negative 9, yes, negative 4 equal to 0, becoming x minus 3 over squared minus negative 13 over 4 equaling to 0. But we need to make x the subject, so we are gonna take 13 over 4 to the other side, becoming x minus 3 over 2 squared equal to 13 over 4. Removing the squares, we are gonna square root on the right hand side, becoming x minus 3 over 2, becoming square root 13 over 4. Don't forget plus, because we are square rooting here, becoming making x the subject to be 3 over 2 plus or minus into root 13 over 2, because the square root of 4 is 2, meeting the condition of the question. Yeah, so let's get now a tricky example also, which must confuses some of us, which will be 3x squared plus 24x plus 12 equal to, since this is an equation, so we need to make the coefficient of x squared to be a positive one. We are gonna be throughout, divide by 3, divide by 3, divide by 3, and also here divide by 3, becoming x squared plus 8x plus 4 equaling to 0. And then we complete the squares as well, being x plus 4 squared minus 16 plus 4 equal to 0. Then it will be x plus 4 squared minus 12 equaling to 0. Then it will be x plus 4 squared equal to 12. Then making x the subject to be x plus 4 equal to plus or minus root 12, making x the subject to be x minus 4 plus or minus root 12. And here, but now we have completed the squares, so we are gonna do on discriminant of the quadratic equation. So by using the knowledge of computing squares, someone can be in quotation to derive a quadratic equation, which they can give you x squared plus bx plus c equaling to 0. Dividing a on all sides, it will lead us to x squared plus bx over a plus 6 over a equal to 0. Computing squares will become x squared bx to a minus b over 2a squared plus c over a equal to 0. Here we have forgot a square, and this x must not be there. So it will be x plus b over, taking these terms, the other side, it will become b over 2a squared minus c over a, and then to be plus b over 2a squared becoming b squared over 4a squared minus c over a, and then it becomes x plus b over 2a squared equaling to 4a squared become b squared minus 4ac. Eliminating this square, we are gonna square root on the right hand side, becoming x plus b over 2a becoming plus or minus b squared minus 4ac squared. Taking this term, the other side, it will become x equal to minus b over 2a plus or minus square root of b squared minus 4ac minus over 2a. When we get the square root of 2, 4a squared, we are gonna get 2a. LCM will remain the same, becoming x equals to minus b plus or minus into root b squared minus 4ac over 2a. This is a quadratic formula. This is a quadratic formula And a discriminant is a value of b squared minus 4ac in x equaling to minus b plus or minus b squared minus 4ac over 2a. So a discriminant is a value of this, a value of this only. So let's see it. Let's see it. So there are some terms we follow in math, and they say if b squared minus 4ac is greater than 0, so there are two distinct real roots, and if b squared minus 4ac is equal to 0, there are equal roots. In brackets, it can be called one repeated root. And when b squared minus 4ac is less than 0, then there are no real roots in that equation. So let me try to sketch for you the graphs of these equations. So if you make a graph like this, x, so it means this graph has two roots, which are here and another one here, becoming b squared minus 4ac greater than 0. And another graph may appear like this, and it's like this, touching the x-axis. So it means this graph has a repeated root. Meaning b squared minus 4ac is equal to 0. And another graph may appear like when it doesn't touch the x-axis, meaning that this one has no roots. Meaning b squared minus 4ac is less than 0. So let me look at an example here. They can give us they can give us to find whether these equations have either a repeated root, has no root, or two real roots. And these equations are as follows. x squared minus 3x plus 5 equal to 0, and another equation is 3x squared plus x minus 6 equal to 0 is 25 x squared plus 20 x plus 4 equal to 0. So they have told us to test whether they have equal roots, one repeated root or two real roots. Let's start with the first one, which is a. By applying b squared minus 4ac, we shall name it this one as a, this one as b, and this one as c. So when we substitute in b is 3, becoming 3 squared minus a is 1 times 1, and c is a positive 5. Yeah, and c is a positive 5, which is times 5, becoming 9 minus, is 9 minus 4 times 1 and times 5, which is a 20, minus 20, becoming a negative 11. And they have told us n b squared minus 4ac less than 0, then it has no roots. So in equation A, it has no roots. Let's go to equation 2, which is b. So b squared minus 4ac. B is negative, is positive 1, which is 1 squared minus 4 times 3, which is 3, having 1. Let me see here, negative 6, negative 12, 12 times 6, which will be 7. 7 try to see 12 times 6, which will become a 72, but a negative times a negative, which will lead to a positive, becoming 72, becoming 73. But they told us when it is greater than 0, it means it has two distinct roots here to become two real roots. And let's go on the third equation, which would be b squared minus 4ac. B, we have 20 squared minus 4 bracket. A is 25 and C is a 4. Here it will become 400 minus 4 times 25 to become 100 times 4, becoming also 400, becoming 0. But they told us when bx squared minus 4x equal to 0, there it has one repeated root which is equal roots. So let's try to see also a different question here. Question here, which will be to find the value of P and Q in equation x squared plus bx plus q equal to 0, where the equation has roots of -1 and 4. These roots are the values of x in that equation, so it will be x equal to -1 and x equal to 4. By making an equation to become x plus 1 and x minus 4 equal to, by completing the brackets, become x squared minus 4x plus x minus 4 equal to 0, becoming x squared minus 3x minus 4 equal to 0. By comparing the equations, we shall find p equal to -3 and q equal to -4. And then there is its part B saying using the values of P and Q, find the constant R in equation x squared plus px plus q plus r equal to 0, where it has equal roots. They told us that for any equation to have equal roots is discriminant, which is bx squared minus 4ac, it must be equal to 0. So let's try to substitute in the values of p and q in the equation, becoming x squared minus 3 px minus 4 plus r equal to 0. So the x squared will be b is 3 squared minus 4. It is it will be a positive 1 here, and c it will be a negative 4 plus r equal to c, minus 4 plus r equal to 0, becoming 9 squared minus, let's see, it will become 4 into negative 4 plus r, becoming 9. No, sorry, it's supposed to be 9 here. Not 9 squared, it's supposed to be 9. Become 9 minus 16 plus r equal to 0. Also here equal to 0. So it will be negative 5 plus r equal to 0. Taking the other side, r will be equal to 5, and so we have found the value of the constant r in the equation that we have given. But now we have completed the discriminant of a quadratic equation, and the next time we are going to try to look at this theory, curve sketching, maximum and minimum, simultaneous equation, and mainly in simultaneous we are going to look only on low, which is sometimes called echelon method. And for today we are gonna stop here, and I'm gonna wish you a nice day, and try to be live tomorrow at around 4 p.m. to 5. We shall be live streaming, so keep that.